Good morning, grade 12s. Today we are going to look at protein synthesis. This is where the proteins are made. The proteins are made. We are going to look at the 3 steps. We have the first one where we say it is transcription. It is when the messenger RNA is formed or is made. And then we have the second one, which is when the messenger RNA leaves the nucleus, because the messenger RNA is made or formed inside the nucleus. Once that has happened, the messenger RNA will leave the nucleus and then it will go to the cytoplasm, attach itself in the ribosome, and that we say it is translation. Now, let's see what happens. The first thing that happens is that we have the nucleus, the DNA inside the nucleus. What happens is the DNA under normal circumstances, it looks like this. This is how the DNA at its rest position look like. And then what will happen when the first phase start is that the DNA will always uncoil. It will uncoil itself, and this weak hydrogen bond that holds the two nitrogenous base will break, and then it will result in 2 strands. As we can see them, it will result in 2 strands. Then what happens? One of the 2 strands will act as a template to form a complementary strand, which is a messenger RNA. How it does that? It will be using the free messenger RNA nucleotide that are found in the nucleus. So inside the nucleus, where we find the DNA, there are also RNA nucleotide that are found there. And this RNA nucleotide will be the one that will be used to form a messenger RNA. Looking at what? At the strand that comes from the DNA. That strand that comes from the DNA will be complementary to the strand which is... Okay, so we've got this strand, and then this strand we are going to see complementary messenger RNA. For example, if we have guanine like this, there will be the messenger RNA. We shall have cytosine. Then for thymine, we shall have adenine. Then for adenine, we shall have uracil, because remember, this is a messenger RNA. In RNA, we don't find thymine. In the space of thymine, we get uracil. And again, we have, remember, it's a code. This is a code. We regard this as a code. Then we have adenine. Again, we are going to have uracil. Then cytosine, we are going to have guanine, and then guanine, we are going to have cytosine. Just like that. Now this is the messenger RNA that has been formed by the DNA right inside the nucleus. Then what is going to happen? The messenger RNA is going to leave the nucleus and go straight to the let me see, yes, is going to leave. Remember, all what was happening inside here, inside the nucleus. So now we've got now that messenger RNA, and the messenger RNA is now leaving the nucleus through the nuclear pores. So it will leave through this pores. It will leave through this pores, That is now the second step. We regard that as a second step, when the messenger RNA leaves the nucleus with the code. Remember, it's carrying the code, leaves the nucleus through the nuclear pores, and then it goes straight to the ribosome. There we are. We see the ribosome. Here is our messenger RNA, which attach itself in the ribosome. Then what will happen is that it is coming, remember, it comes with the codon. This messenger RNA is carrying the codon. I'm going to just make an example. Let's say it has got this one is adenine, the yellow one. The pink one is guanine, and then the blue one is maybe cytosine. Then the yellow one again is cytosine, and then this one is guanine, and then this one is adenine. Right? Now this is the messenger RNA with the codes. So these are the codes. They are triplets codes. We count them as 3, 3. They are 3. They are triplets, and they are code. Now it has attached itself in the ribosome with the messenger RNA with those codes that we can see there. The next thing is that now we shall see the tRNA. Here is our transfer RNA. It will come with its anticodon with the correct amino acid. So let's say we are looking at this codon, these ones. I remember I said this is guanine. Sorry for that. This is cytosine. This is adenine. So the anticodon for guanine, we shall have cytosine. For cytosine, this one, we shall have anticodon guanine. And then for adenine, we shall have uracil. Remember, there is no thymine in any RNA. So you have your code, your codon from messenger RNA. that was made inside the nucleus using the messenger RNA and the strand of DNA. Then you have your anticodon, which are brought by the transfer RNA together with the correct amino acid that was coded by the messenger RNA. Then we are going to have another transfer RNA coming, and if we have C here, the transfer RNA will have G, and then if we have a G in the codon, it will have C, and then if we have A in the codon, it will have U. It will be continuously done like that until we have all these amino acids as you can see them. So these are amino acids that were made copying from the messenger RNA that was brought in the ribosome. They are carried, or they are held by the peptide bond. All these amino acids are held by the peptide bond. Once we have many amino acids, then the protein is being formed. This is how we make a protein. As simple as that. If we may revise it, we started with 1. Right inside the nucleus, we've got the DNA. That's step 1. The DNA inside the nucleus will unwind. It will unwind. It will unwind, uncoil, then it will expose the nitrogenous bases. Once those nitrogenous bases are exposed, remember when it's uncoiled and unzip, we remain with 2 strands. We have 2 strands. Only one of the strands is going to be used to form the messenger RNA using the M nucleotide that are found inside the nucleoplasm. Once the messenger RNA is formed, with the code is going to leave the nucleus through the nuclear membrane, goes to the cytoplasm where it will attach itself in the ribosome with that code. Once that has happened, we are going to get the transfer RNA coming with the correct amino acid with its anticodon. The process will continue until we have many amino acids which are held by a peptide bond, and the protein will be formed. Thank you very much for watching this video. I hope we'll meet next time in the next video. Thank you.